Hello students, welcome to Educate. In the last video, we have discussed about the order of reaction. In this video, we will discuss about the molecularity of reaction. What is order of reaction? Just I recap you. In the rate law expression, there is various reactants involved. So, order of reaction is the summation of power of the reactants involved in rate law expression. Order of reaction is the summation of power of reactants in the rate law expression. And now we discuss about molecularity of reaction. What is molecularity of reaction? Molecularity of reaction is the number of reacting species. Molecularity of reaction is the number of reacting species which must collide simultaneously in an elementary reaction is called molecularity of reaction. Molecularity of reaction is the number of reacting species that may be atoms, molecules or ions which must collide simultaneously in an elementary reaction to bring about a chemical reaction. That is called molecularity of reaction. Actually, a reaction takes place when the reacting species collide and from somewhere there will be cleavage of bond and formation of new bond. Firstly, let's see here molecularity of reaction. Here, about the molecularity of reaction, here given in the examination, they are given in the NCERT book, this bold line, the number of reacting species may be atoms, ions or molecules taking part in an elementary reaction, which must collide simultaneously in order to bring about a chemical reaction. That has been written already. You may also write the number of reacting species which must collide simultaneously in the elementary reaction to bring about a chemical reaction. So, guys, keep in the mind here about the molecularity of reaction. The molecularity of reaction is valid for only elementary reaction. What is elementary reaction? Reaction which takes place in a single step. That is called elementary reaction. The reaction which takes place in a single step, that is called elementary reaction, and the reaction which takes place in more than one steps, that is called complex reaction. Okay, so in the elementary reaction, that means which takes place in a single step, how much reacting species collides, that is called molecularity of reaction, that is given here. Now, what is complex reaction? That's also we have discussed. Let's see here. In the complex reaction, here as for example is given about an elementary reaction, about this one. Ammonium nitrite. Name of this compound is ammonium. NH4 is ammonium and NO2 is nitrite. This name is ammonium So when ammonium nitrate dissociates and there is formation of N2 and water, here only one reacting species is involved. So elementary here molecularity of reaction will be 1. Here in this reaction 2 moles of HI gives the formation of H2 and I2. This one here, the two hydrogen molecules collide together and there will be a formation of here H2 and I2. So in this reaction, in this elementary reaction, there is involvement of 2 molecules. So molecularity of reaction here is 2. Here molecularity of reaction it will be 2. Here, now, another example here, when 2NO react with oxygen, when 2NO react with here NO, that is called nitric acid, here nitric oxide, N2O, that is called nitrous oxide. Just for the recap, here NO, that is nitric oxide, and 2O is called nitrous oxide, which is also called laughing gas. Laughing gas. By spelling this gas, person starts laugh. So that's why N2O, that is nitrous oxide, is called laughing gas. So what happened here? The nitric oxide reacts with oxygen. There is formation of nitrogen dioxide. So in this reaction, there is involvement of, in this elementary reaction, there is involvement of 3 reacting species. That's why this reaction is a type of, here molecularity of reaction will be 3 and it will be called tri-molecular reactions. Okay. Another example here given, that KClO3, potassium chlorate, react with FeSO4, ferrous sulfate. Here the potassium chlorate react with ferrous sulfate in presence of H2SO4, and there is formation of KCl and Fe2SO4. This one is here. So this reaction here is a complex reaction. This reaction here is a complex reaction. It's a balanced chemical equation. But this reaction is not the elementary reaction. This reaction is a complex reaction. Usually, the molecularity of reaction are not greater than 3. The molecularity of reaction greater than 3 are rare. This reaction here, in which the potassium chlorate react with ferrous sulfate and sulfuric acid, and there is formation of potassium chloride, ferric sulfate and water. That reaction here is a complex reaction. This reaction is a complex reaction. Another example of a complex reaction is here H2O2 here. This one you may think that it's a bimolecular reaction, but here this reaction is also a complex reaction. Why? Here it has been observed the rate of reaction is directly proportional to concentration of hydrogen peroxide and that of iodide ion. So this reaction is a complex reaction because this reaction takes place in 2 steps. What will be the molecularity of reaction here? That also you will have to watch out by observing the order of reaction. So here order of reaction is directly proportional to, rate of reaction is directly proportional to concentration of hydrogen peroxide and iodide ion. So this reaction is complex reaction. Why? Because firstly, the hydrogen peroxide reacts with the iodide ion. 1 molecule of hydrogen iodide, 1 molecule of hydrogen peroxide, 1 molecule of hydrogen peroxide react with the iodide ion, and there is formation of H2O and IO minus. So this step is one step is this one. Second step is when this H2O2 react with the intermediate IO minus. This intermediate IO minus react with this hydrogen peroxide, and there is formation of water, iodide ion and the oxygen molecule. Both here, in both the cases, this step here in this one is elementary reaction and this reaction is also elementary reaction. Both the reaction is elementary reaction, and in the second step, the intermediate IO minus is reacting with hydrogen peroxide. So this one here, first step is the rate determining step. In the first step, there is formation of iodide ion and this IO minus ion, and this IO minus react with H2O2, and there is formation of water, iodide ion and oxygen. So this one is here in this case, so first step is the rate determining step. In any reactions, the slowest step is the rate determining step. In any step, because here why it is for rate determining step, because in this reaction is slow, this reaction, first reaction is slow and second reaction is fast. So in any reaction, the slowest step is the rate determining step. Keep in the mind, slowest step is the rate determining steps. You can also verify this one in our day-to-day life. So this one, rate determining steps, this one. Next one is difference between, in the examination, 12th board examination, frequently asked question is write difference between molecularity of reaction and order of reaction. You will have to write in the questions, 2 marks question asked in 12th board examination, that molecularity of reaction and order of reaction. So how to write to bring about a chemical reaction? So during that course, you will have to divide your page in 2 parts. In one steps, you will have to write molecularity of reaction. Molecularity of reaction, and in second, order, here this one, and second, order of reaction. Order of reaction. First one, the definition. I have already taught you what the definition of molecularity of reaction and order of reaction. Molecularity of reaction is the number of reacting species, that is atoms, molecules or ions, which must collide simultaneously in the elementary reaction to bring about a chemical reaction. That is called molecularity of reaction. And order of reaction is the summation of power of the reactants in rate law expression. So first one will be definition, molecularity of reaction. You may write that molecularity of reaction, the number of reacting species, the number of reacting species, that means atoms, molecules or ions, which must collide simultaneously, So molecularity of reaction is the number of reacting species which must collide simultaneously in elementary reaction to bring about a chemical reaction. And order of reaction is the sum of sum of power of reactants in rate law expression. So order of reaction is the sum of power of reactants in rate law expression, that is called order of reaction. Second one is here, molecularity of reaction is applicable for elementary reaction. You have studied here. So molecularity of reaction is applicable for elementary reaction but the order of reaction is applicable for both elementary reaction as well as complex reaction. The molecularity of reaction is applicable for elementary reaction only, and the order of reaction is applicable for elementary reaction as well as for the complex reaction. So molecular reaction applicable for elementary of this or molecular of reaction is applicable for elementary reaction only, while the order of reaction is applicable for both elementary reaction as well as for the complex reaction. Okay, and here third one is here, that is only relationship. So when you will have to write the answer of the question, that write difference between molecularity of reaction and for the complex reaction, then you will have to divide the page in two parts. In first point will be the definition, and second one, the molecularity of reaction is applicable for only elementary reaction, and the order of reaction is applicable for elementary reaction as well as for the complex reaction. And this one points you should keep for the 1 marks question. You know, these days there is MCQ question also asked in the 12th board examination. So you should keep in the mind that when for the complex reaction, that means the reaction which takes place in more than 2 steps, 2 or more than 2 steps. The reaction which takes place in 2 or more than 2 steps, that is more than 1 step, that is called complex reaction. So in complex reaction, the order of reaction is the molecularity of reaction in slowest step. Okay, so you should keep in the mind this one. In a complex reaction, order of reaction will be equal to the molecularity of reaction in slowest step. Okay, this point is quite important for you for the NEET examination as well as for the IIT main examination, more important for NEET examination and CUT examination. For the CUT examination, this concept is quite important. There is high chances of asking from this topic, this point in the CUT examination. Okay, now that was about. Now let's see how to solve this numerical. There is a reaction here in this question 3.3. There is given, there is a reaction and rate law is given here. Rate law expression is given. So rate law is given. What is the order of reaction? So simple, sir. 1.2 plus 2. So order of reaction here, order of reaction will be equal to 1 by 2 plus 2. 2 to the 4, 1 5. So 5 by 2 or 2.5. Second 3.24 questions. This type of question has been asked in 12th board examination, and this type of question may also asked in CUET examination as well as in NEET examination. For IIT main examination may ask, but not so much chances, but it has high relevancy for the 12th board examination, CUET examination as well as for NEET examination. So let's see here. Question is, X is converting to Y. That means X is a reactant and Y is a product. And it is second order kinetics. Second order kinetics means order of reaction is 2. concentration of X has increased to 3 times. So what will be the rate of formation of Y? So let's see guys, watch out carefully. What is here? Reaction is X is converting into Y. This one here, rate of reaction is minus dx by dt. That is also equal to dy by dt. That means rate of reaction is equal to rate of decomposition of X, and that is also equal to rate of formation of Y. So in indirectly form, the question is asking that when the order of reaction is 2, then if the concentration of reactant X will increase to 3 times, then what will be the rate of reaction? So let's see here. So you know already rate of reaction is equal to rate for this one, second order reaction. The rate of reaction will be equal to rate constant into concentration of reactant X, that to the power 2, since the reaction is second order. So when we write R1 by R2, so that will equal to K X upon X squared. That upon K, concentration become 3X here, that's a square. So R1 by R2 will be equal to rate constant into concentration of X, that's a square, and the final concentration has become 3X. So 3X, K will cancel out. So that will be equal to X square upon 9X square. So X square cancel out 9. So R1 by R2, that will be equal to 1 by 9. So R2 will be equal to 9R1. So rate of reaction when the concentration of X will become 3 times, then the rate of reaction will become 9 times. So here, very simple here. So when the concentration of reactant has increased to 3 times, then obviously the rate of reaction will become 9 times of the previous rate of reaction. Okay guys, very easy question, and this question will ask in 1 marks in 12th board examination, and in CUET examination the probability of asking this question is very high, and there is also probability of asking this type of question, not directly, then this type of question is also. So there is the probability of asking this question in NEET examination, as well as very high probability of asking this question in CUET examination. Now let's see. Now we proceed on the another topic that was about the molecularity of reaction. Now we discuss about integrated rate law equation. This integrated rate law equation. So let's see here how to do integrated rate law equation. So we derive here integrated rate law equation for zero order reaction. You know already rate of for zero order reaction, so rate of reaction will be equal to rate constant into concentration of reactant to the power 0 for zero order reaction. For zero order reaction, rate of reaction is equal to rate constant into concentration of reactant to the power 0. Now rate of reaction is, we can write minus dr by dt. Any reaction here is taking place, reaction this one, that is giving a product P. So rate of reaction is rate of decomposition of R, this one, so that will equal to K, and concentration of reactant to the power 0. Anything to the power 0 will be equal to 1. Like 5 to the power 0, that will equal to 1. 10 to the power 0, that equal to 1. So if there will be 0, power 0, then that's 1. But like 5 to the power 1, that will equal to 5. 10 to the power 1, that will equal to 10. Yes, 5 to the power 2 is, that means 5 into 5. Power means how much times that will have to multiply. So 5 to the power 0 means 5 will not have to multiply any time. So that will be obviously 1. So minus dr by dt, that will go to here k. You will have to make always dt minus k dt in zero order reaction as well as in first order reaction. Guys, for IIT main examination, you will have to watch out how I derive this one in zero order reaction and in first order reaction. When I will make the separate video for the IIT main examination, then I shall also derive for the second order reaction and third order reaction. In the IIT main examination, questions oftenly asked from the integrated late law equations for the second order reaction, not for the first zero and first. Okay, so you will have to, how I derive that, you listen carefully. Same concepts you will have to apply there, and which will be important for IIT main examination. And in NEET examination, questions directly asked. Okay, so let's see here. So minus dr by dt, that is equal to k. So dr, that will equal to minus k dt. Now integrate both sides. So dr, that will be equal to integration of minus k dt. Integration of dr will be r. Integration of dr, that will equal to r, and here k is constant. So minus k integration of dt. Now when you will integrate the dt, so when you will integrate the dt, so what will happen here? So dt integration will be t and constant of integration. So concentration of reactant, that will be r, will be equal to minus k t plus constant of integration. This is equation 1 here. So concentration of reactant will be equal to minus kt plus constant of integration. Now at t equal to 0, that means when reaction has just started. At t equal to 0, that means when the reaction has just started. At that case, at t equal to 0, concentration of reactant will be equal to initial concentration of reactant when the reaction has just started. So concentration of reactant will be equal to initial concentration of reactant. So here is in this equation, put the value. So R naught will be equal to minus K into 0 plus constant of integration. So R naught will be equal to constant of integration. Our main purpose is to find out the constant of integration. Now put this value in equation 1. So concentration of reactant, that will be equal to here minus Kt plus R naught. So here Kt will be equal to R naught minus R, and K1 you will have to find out. So that will be equal to R naught minus R by T. This is here for the rate law equation. So rate constant will be equal to initial concentration of reactant minus concentration of reactant at a particular instant of time, that upon time interval. Okay, that was about the rate law expression. Now we also discuss from here about the half-life period. Or leave that. We discuss about the half-life period separately. So keep in the mind there when I shall derive the half-life period for zero order reaction as well as for the first order reaction. So this one here. Now let's see integrated late law equation for the first order reaction. Before that there will be a graph. How's the graph? The expression was here, recall that K is equal to R naught minus R by T. That was, or there was the equation was here same. So there was another equation, R equal to R naught minus KT. That was, you just recall. This one, R equal to minus KT R naught, that we have discussed. So the equation in which, so equation was R equal to concentration of reactant equal to initial concentration of reactant minus KT. So this graph, when we will plot the concentration of reactant versus time period, when we will plot the graph of concentration of reactant versus time period, then R naught will be the intercept. From R naught, there will be a decreasing graph. If suppose there be a reaction, this is not here. Suppose if there, that would be R naught plus KT. Suppose this one. So how the graph? There be R here this side and T this side. Suppose concentration of reactant this side and time period this side. So from R naught, there will be an increasing graph like this. But it is here minus KT. That means from R naught, there will be decreasing graph. So maximum value will be R naught and that graph will be a decreasing graph. So slope will be minus K. Slope here will be equal to minus K. This one. Because decreasing graph. Slope will be what? This value upon this value. Means vertical, that upon horizontal. So change in concentration, that upon time. That is slope. Slope is actually also called as tan theta. So mathematics, the students of mathematics are already aware about this one. So slope is this one. So graph will be like this. Okay. Example of zero order reaction here is ammonia. The decomposition of ammonia into nitrogen and hydrogen. The decomposition of ammonia into nitrogen and hydrogen is an example of zero order reaction. Because the rate, if you will increase the concentration of reactant, that not means the rate of reaction will increase. Okay. As if we add the water to the plant, that not means there will be more growth in water. So we will have to do the watering through a certain limit only. After that, watering will be wastage or maybe harmful for the plants also. So in the same way, if you will increase the concentration of reactant, that not means that there will be increment in the rate of reaction. Okay. Now let's see first order reaction. Now we will discuss about the integrated rate law equation. Integrated rate law equation for the first order reaction. Let's see here. As we have derived for the zero order reaction, in the same manner the integrated rate law equation will be derived for the first order reaction. So let's see. Same here in first order reaction. In first order reaction, rate of reaction will be equal to K into concentration of reactant to the power 1. Here to the power 1, nothing means power 1. So rate of reaction will be equal to K, rate constant, into concentration of reactant. Rate of reaction can be written as minus dr by dt. Always you will have to make the minus K dt. Either you derive in the zero order reaction or in first order reaction or in second order reaction. You will have to make minus K dt. So here dr by r, that will be equal to minus K dt. Now integrate both sides. So when you will integrate dr by r, that will equal to integration of minus K dt. Now integration of dr by r, that will be equal to log r to the base natural exponent. This one, log r, means natural log. That will be equal to integration of minus k dt. Minus k will go that side. So minus k and integration of dt, that will be equal to t plus I. So minus k, you may write here. So log r minus kt plus constant of integration. Now at this is equation 1. At t equal to 0, that means when the reaction has just started, so the concentration of reactant will be equal to the initial concentration of reactant. At t equal to 0, concentration of reactant will be equal to initial concentration of reactant, that means R naught. So here log R naught, that will be equal to minus k into 0 plus I. So log R naught will be equal to I. Put the value of I in equation 1. What we will get? So log R will be equal to minus kt plus log R naught. So kt will be equal to log R naught minus log R. Log A minus, watch out here, log A into B, that equal to log A plus log B. Log A upon B will be equal to log A minus log B. And log A to the power x equal to x log A. That is here. It is natural log. Same will be valid for log to the base 10. So kt equal to log R naught minus log R. So k will be equal to log R naught minus R, and that upon 1 upon t. When you will have to convert natural log into log to the base 10, then you will have to multiply by 2.303. So k will be equal to 2.303 upon t log R naught by R to the base 10. Log means log to the base 10, and Ln means natural log to the base e. Okay, so k equal to 2.303 upon 2.303 upon t log R naught by R. This derivation. Now we also can plot this graph. Here our expression is, our final expression is here log R equal to minus kt log R naught. So when we will plot the graph, when we will plot the graph of log R versus time period. So what will be here? Minus kt. So there will be decreasing graph, and maximum value will be log R naught. So the maximum value will be log R naught. From here that will decrease. So this is here intercept. Intercept will be log R naught, and slope will be minus k. Okay guys, this one very easy. Now let's see. Just verify from the equation here. Same derivation here. Here. In the first order reaction, log R versus t. So intercept is log R naught and slope is minus k. Okay. Same here, log R naught by R versus t graph. So same here, this one will be an increasing graph. What the expression actually was? Keep in the mind. What was the expression? K equal to 2.303 upon t log R naught by R. That was. So time will go this side, time will go this side. So KT will be equal to 2.303. You may also write or T equal to 2.303 upon K log R naught by R. This value is constant. So T versus log R naught by R, that will be an increasing graph. If T will increase, log R naught by R will also increase. So that's why that will be an increasing graph. The graph of log R naught by R versus time, that will be an increasing graph. This concept will have application for CUET examination, and its importance for the IIT main examination should not be denied. Okay, and this one is this concept is highly relevant for the CUET as well as 12th board examination and the NEET examination very well. So now that was, this question was asked frequently asked in 12th board examination, and these concepts will have the application to solve the questions in NEET examination as well as for CUET examination, and it is also helpful for the IIT main examination. So let's see here. There is a reaction. What's the read the question? Reaction is here and nitrogen pentoxide that dissolves into nitrogen dioxide and oxygen. The initial concentration of reactant has been given, that is N2O5 has been given, that is 1.24 into 10 power minus 2 mole per liter. The concentration of N2O5 after 60 seconds was what? That has been given. So calculate the rate constant of the reaction. So very easy, put the formula and get the result, because you know the formula. You have already studied here KT or K equal to rate constant 2.303 upon T log R naught by R. So put the formula and get the result. So 2.303, time is given here 60 minutes. So upon 60 minute here, log here R naught initial concentration was given. How much? 1.24 into 10 power minus 2. 1.24 into 10 power minus 2. That is mole per liter. That upon here 0.20 into 0.20 into 10 raised power minus 2. That's mole per liter. So this will be cancel out. Now 10 power, this one cancel out. .2 here. So log 6.2, that is equal to 2.303 upon 60, that much minute inverse, and log 6.2. So how you find out log 6.2? So there is log 6.2, you can write log 6.20 goes on the log table of the back side of the NCERT book. Goes on that. So in that books you will find out here 1, 2, 3, 4 like that here, like 10, 11 to, that will start from 10, 11, 12, 13 like that, 14, 15 like that. So goes on here till 62 will be there, and this side will be chart here, that will be here, and this side 0, 1, 2, 3, 4, 5, 6, 7, 8 like that, and 9. That will be given. So goes on 62 here, and on the 0 of this one here, this one, what will be the value? Put the decimal after 1 digit. Okay, that will be, so that will be equal to here 2.303 upon 60 log 62. That find out, and after that, after calculating this one, you will get the value 0.0304 per minute. Minute inverse for here, minute here. So K inverse is that much. So here the rate constant has the unit of time inverse. That means whatever we have done, that's correct. Okay guys, that question was very easy. This one. Now we will discuss about the reactions in which there will be involvement of the gases. So today for this class it will be till here only. In the next class we will discuss about this one, this question, and the reaction in which there be involvement of gases. Okay guys, so it's all for the today class. In the next video we will discuss about the first order reaction in which there be involvement of gases. That means gases when react together and form the gas. About that we will discuss. It's all for the today class. Thank you, Team Educate.